This continues section 4.4, and we are solving algebraic equations where we have simplifying involved as well, which could include the distributive property as well as combining like terms. So part A here of example 24, what we see on the left-hand side is an expression, of course. And this expression, we have two like terms and one unlike term. And then on the right side, we also have an expression where we have two like terms. So on the left, we're going to say 6a minus 5a, which just gives us an a, and then plus a negative 2. And then on the right-hand side, we have a negative 9 plus 1, which gives us a negative 8. And now we have a simplified algebraic equation, and from there we can apply our addition properties and or our multiplication properties. So I need to remove the negative 2 from this left side. It's being added to the a, so I want to add its opposite. So I'm going to add a positive 2 to this side and then to this side as well, because I want to create an equivalent equation. What I do to the left, I do to the right. And then in simplifying that, a plus 0 is a, negative 2 plus 2 is 0, and that's equal to negative 8 plus 2, which is a negative 6. And there we go. That's my final answer. A equals negative 6. Now moving on to my next example here, I have negative 5a plus 6 is equal to, or negative 5a plus 6 minus 4a is equal to 7a plus 8 minus 7a. So on the left-hand side over here, I want to simplify this expression. So 5a minus 4a is equal to a plus a 6. And then on the right-hand side, I want to simplify this expression. 7a minus 7a is 0, so I won't write it, and then plus 8. So now I have the simplified equation, a plus 6 is equal to 8. Now I can see that I need to remove the 6 from this side so I can make the a stand alone. So I'll add its opposite, a negative 6, to both sides, because what I need to do to the left, I need to do to the right as well. And now I have a plus 0, which is a, and 6 plus negative 6, which is equal to 0, so I don't write it, and a minus 6, which is equal to 2. And now I have my solution for equation B. Moving on to part C, I have a distributive property in this problem. So I'm going to use the distributive property here on the left-hand side first. So now I have a 2c plus 2 times 5, which is 10, and then plus a negative 3. And then I'll need to simplify this side further by combining the like terms. So now I have 2c plus combining these like terms, which is going to give me a positive 7. Now that I've simplified the left-hand side completely, I'm going to go up here and I'm going to simplify the right. So on the right-hand side, I'm going to distribute here, and I'm going to distribute here. So 3 times c is going to give me a 3c, and then plus 3 times a negative 3, which is going to give me a negative 9, and then plus a 2c, and then plus a 1. Now on this side, I have like terms in the c terms, and I have like terms in these constant terms, and so I'll want to combine those like terms. 3c and 2c gives me 5c, and negative 9 plus 1 gives me a negative 8. Now from there, I have a simplified algebraic equation. And from this simplified algebraic equation, what I want to do is I want to move the variables to one side. The 5c is larger over here, so I'm going to add the opposite of 2c to both sides so I can get all the c's together. And I'm going to put that equal sign in there to show you that those are equal. And now I'm going to have the algebraic equation 7 is equal to 5 minus 2, which is 3c, plus a negative 8. And finally, I want to move this constant over here to be with this other constant. And so I'm going to add a positive 8 to both sides, and that's going to be giving me 7 plus 8, which is 15, and that's equal to 3c. Finally, I need to remove the numeric coefficient, so I'm going to multiply both the left and the right side by the reciprocal of the numeric coefficient, which on the left-hand side, that simply looks like division because multiplication by a reciprocal is a division, and that gives me that 5 is equal to c. And remember, it's perfectly acceptable to say c is equal to 5. And that will be our final answer. We'll do the next problem, part D,